Okay, so say we're doing a sine wave. Do you remember doing degrees into radians when you're switching the triangles?
Yep.
So remember we've gone through all that. 180 degrees is essentially pi.
Yeah.
2 rotations is 360. So we have this as our pi. This is 2 pi, right?
Mm-hmm.
This is going to be half pi at 90 degrees. And this is going to be 3 pi over 4. Okay? 3/4. All right. Yeah, that's right.
3 pi over 2.
Sorry, that's it. Over 2. Oh my God, there you go. 3 pi over 2. So that's 1.5 pi. Yeah, okay. So we're doing our sine wave at 90. It's here. At pi, it's at 0. Negative 1 and 360. So essentially, here's our wave. Goes up, down, and up. Okay?
Mm-hmm.
So this is our wave. This is our familiar ones. And there's always the in-betweens. This is where we kind of want to go into our special triangles. The first question says, prove that 2 sine squared theta equals 1. And theta is equal to 3 pi over 4. Okay. Now, does she want you... Oh, here we gotta make sure. Okay. What you can do, instead of just transforming a wave, because you've done transforming before, you remember that this would be A and such.
Yeah.
What we can do is just try to isolate for sine. Okay?
Mm-hmm.
So think of it, we have this. We want to bring our 2 to the other side of the equation. Okay? So I end up with sine squared theta is equal to 1 over 2.
Mm-hmm.
Okay? And now I want to get rid of our square root on this side. Okay? So if I want to get rid of the square root on this side, I would change it to, I'd square root both sides, so I end up with sine theta is equal to root of 1 over root of 2. I have to root both. I can solve root of 1. Root of 1 is just 1 over root 2 is equal to sine theta. Now the question is, from our rules, what does theta have to be equal to 1 over root 2? Do you remember our special triangles at all?
Yeah.
Yes. So we have our special triangles. So let's say we have, for instance, I know off the top of my head, 45, 45 is going to give me 1, 1, root 2, right? So if I'm doing sine is opposite over hypotenuse, right? So sine theta is opposite over hypotenuse.
Mm-hmm.
If say this, my 45 is my sine, my opposite, and my hypotenuse would be 1 over root 2. But the only thing is I have to prove now that 3 pi divided by 4 is a 45-degree angle. Okay? Okay, so you can either punch this into a calculator, 3 pi divided by 4, or what you can do is, again, think of it, bring this down here, think of it like rotations, okay? And if it says 3 pi over 4, what that means is 3/4 of a full rotation, or of pi, right? So we're talking about 3/4 of pi. Well, we know that if we go up to here, so if I rotate this far, that's half of a rotation. So 3/4 of a rotation is essentially giving me a triangle that's halfway between these, right?
Yeah.
And if I know this is 90 degrees, I know that halfway between is going to be 45, right?
Mm-hmm.
So now that when I use my special triangle, sine of this, well, my hypotenuse is root 2, and my opposite side is 1. So we know this is a proper, we know this could be a solution for 2 sine, what's the question say? 2 sine squared theta equals 1. We know that that can be a solution. Does that make sense?
Yeah.
Okay, so that's going through it that way. Okay, so in this question here, they want to solve for x. Solve x to the nearest degree between 0 and 360. Okay, we're going to replace. I'm going to say let sine x be, we'll use a different variable because they're using x. We'll just call it maybe a, okay? So what I'm going to replace this now, what this is going to say is 2a squared minus a is equal to 0. Okay? So if I take a look at this, I can now factor this. Okay, I can take a out of both of these, so I'm left with a, and then I have 2a minus 1 equals 0. Now I can split this equation. I have a is equal to 0, and I have 2a minus 1 is equal to 0. Okay, and we always want to isolate for just a. Well, we finished this one here. A is already 0. In this one, we're going to have 2a, 1, a is equal to a half. Okay? So all I have to do now, though, is remember I replaced sine x with a, so I substitute sine x back in. So my options are sine x is equal to 0 or sine x is equal to 1/2.
Why do you have to put that statement?
Just to show that you know what you're doing, like what you're planning to do, that you're not just changing things. It's essentially to show that you recognize that you're taking a larger value essentially and simplifying it so that you can see the question in a different way. That's why we always have a let statement. So this represents that. If you went from here and then jumped into here, I have no idea that you know exactly what you're doing, or you're just throwing different letters in. So it's essentially to show whoever's reading your work that you have an understanding of what you're doing. Okay? So you throw a let statement in there. So we have sine x is equal to a half, and sine x is equal to 0. If we look at a sine wave, we know that sine at 0, so when x is 0, it could be 90, it could be 0, right? Those are two options. And then sine at a half, well, then we got to go back into our special triangles to solve that one. So here are your options. If you're allowed to use a calculator instead of using special triangles, all you have to do is, we know on a sine wave that this is going to give us two options. This is going to give us x is equal to either 0 degrees or 90 degrees, right? In this one, what you can do is bring sine to the other side. So we have x is equal to -1 of a half. And you can just plug that in to solve for x, and it'll give us at least
30 degrees.
30 degrees? Yeah, it should only give us one value, because in this question, it's between 0 and 360. Because sine waves go on forever, you have 30 degrees. If it said it was between like 0 and 720, you'd have 30, and your calculator won't tell you this, but you'd have to add 360 degrees to that also as an option. So you'd have 30, and you'd have 390, because it's between 0 and 720, if that was the parameters. But because this one's between 0 and 360, you only need 30. Does that make sense?
Yeah.
Okay. So actually, we missed a couple. So let's draw our number. Okay, here we go. So the question says between 0 and 90, right? And we quickly figured out that, say that's 1, and there's -1. We know a sine wave looks like this. It's not always the easiest to draw here. There we go. And our answers were sine x equals 0, correct? And sine x equaled a half. Okay? What you need to realize is that what they're doing is they're giving us two options. First of all, option 1 is at 0. We'll do it in blue. So actually, it hits this line 1, 2, 3 times. So because it hits it 3 times, and we'll, whenever I draw a line, this thing moves very, very slow. I guess I can talk. Here we go. So this is 1, 2, 3. Okay. Think of it as a straight line between those 2 points. Well, our 3 options are 0, 180, and 360. And then again, at a half, which would be here. So let's go straight. There we go. Our sine wave is going to pass twice. Okay? And we know that the first time it passes, You used a calculator and figured out it was at 30, right?
Yep.
So we knew that 30 was an option. 30, if you can think about it, is also 60 degrees away from 90 to the left. So the idea here is I shouldn't do that in blue. We were 60 degrees away here.
Mm-hmm.
So the other option, we know that's here. Well, we know these are symmetrical lines. So the other way on the way down is also going to be 60 degrees away from 90. So what would 90 plus 60 be? 150. So we have 1, 2, 3, 4, 5 options. 0, 180, 360, 30, and 150. Does that make sense?
Yeah.
Okay. 10A. Same idea. We're going to need We're going to need a let statement here.
Mm-hmm.
Let theta. Sorry, not just theta, but I want cos theta. I want to get rid of my trig identity so I can make this a quadratic equation. So, sorry, I keep hitting the wrong button. There you go. Let cos theta equal, we'll say x in this instance. So our new equation becomes 2x squared plus x minus 1 equals 0. When you do factoring, do the factors of the first and the last numbers, then
I take the product of the AC and then whatever.
Did I ever show you the other way of factoring?
You showed it to me, but I didn't.
You didn't
know how
quite
to
get it.
do
Okay, so you do products of A and C, and then whatever adds to it. Okay, So then your answer here is gonna be 2x x is equal 0, and then I'm trying to think of it the way you do it. If that's your product's negative 2. I can't even think of the way you do it. I'm going to try it quickly the way we would. It's going to equal 1, 2, 1. This is going to have to be negative. So, would you get 2x minus 1 and then x plus 1?
Yeah.
Yeah? Okay. You know how to do the factoring part? That's easy?
Yeah, it was when it comes to like really high, like 6x. When it comes to really,
It becomes difficult.
Yeah.
Yeah, the way I do the factoring is it's simplified. No matter how large the number is, it can be easy. It gets convoluted. Like the larger this is and the larger that number, the more factors they have, it becomes a little more difficult. But to me, this is the easiest way of doing it. I'll show you again. Do you want me to show you now?
Yeah, with a higher number though.
Okay. Well, let's finish this question and
Alright.
get a higher number one after. So we have this right now.
Mm-hmm.
Let's split these. So we get 2x minus 1 equals 0, and x plus 1 equals 0, right? Bring the 1 over, we get 2x1, x is equal to a half, and our other option is x is equal to negative 1. Now, x actually stands for cos, so let's now finally replace that. Cos theta is equal to a half, and cos theta is equal to negative 1, okay? So now cos theta to a half is going to be different in terms of our answers. You're allowed to plug in a calculator, right?
Mm-hmm.
So if you do these, you're going to get probably 30 degrees. I think you're going to get 30, 180, and 330 maybe? Tell me if those are right. Okay, so sorry. If cos a half is 60, not 30, that then means, what's your other one going to be? Do you know? Remember, the lines are symmetrical, so you know that our cos, starts at 1, right?
Mm-hmm.
Comes down, touches negative 1 at 180. Okay, so, and here's the other one option, right? Half. So you know we have a half here, and we figured out that it's 60. Well, if this is symmetrical, it's 60 from 1, and then here's the other time it hits 1, right?
Mm-hmm.
Well, if it's 60 away from there, and this is at 360, if we go 60 to the left of that, what are we going to get?
62.
Yeah. So we go backwards 60. 300. So that'll be our other option. right? Because at a half, it's going to hit that. And we know at negative 1, it's just tangent to it at 180. So we get 60, 180, and 300 as our 3 answers. Okay, and when you converted these, you know, one way to convert them is you take the numbers, 60 pi 180, yeah, and just reduce the fraction.
Yeah.
So you end up with pi over 3. This one's going to obviously be 180 divided by 180, so you're just going to have pi. And in the other one, you have 300. Oh, sorry, don't do it there. 300 pi over 180. So when you reduce them, what can you divide by? 60? Yeah, you can divide both by 60, so you get 5 pi over 6, which is exactly what you got, right? Okay. So how I knew this was 300 is I know that this is symmetrical from its point, okay?
Mm-hmm.
So I know that from 1 and 1, this is an entire period, okay?
Mm-hmm.
So when I plugged it in, I discovered this was 60. Now, I didn't know it was 60 off the top of my head. We just figured that out. But I do know what that means is from 0, it's 60 degrees to the right.
Mm-hmm.
So if this is going to be symmetrical, the other point here is at 360 degrees. If I went 360 inwards, I'm also going 360 again sorry, not 360. If I went 60 degrees inwards to get to this point,
Mm-hmm.
I know from here I'm going to go 60 degrees inwards again. The only difference is I was going to the right on the first one. This one I'm going to the left. So I went 60 degrees to the right. Here I have to start at 360
Mm-hmm.
and go 60 degrees to the left. So essentially I subtract 60 from 360. On this one we added 60 to 0.
Mm-hmm.
Does that kind of make sense?
Yeah.
Because we know it's going to cross at 2 times, right?
Mm-hmm.
We just got to figure out what those 2 times are.
So you always do that for the rest of the book?
Yeah. You got to figure out how many, because on your calculator it's only going to give you one option, right?
Mm-hmm.
It'll give you the one option, and then you kind of graph the wave. How many times does half touch that wave? Like in our other one, we saw that sine touched it twice. 0 touched a sine wave 3 times, so we had 5 different answers for possibilities. Okay. So if you couldn't use a calculator and you had to solve this using special triangles, we have our 2 special triangles, option 1 and option 2, right? We have to have them memorized.
Mm-hmm.
So first of all, we know that we have this option here, okay, half. So we know that cos is also known as adjacent over hypotenuse, right?
Mm-hmm.
So we have to figure out, we have to reverse engineer what would be adjacent and hypotenuse that would create a 1/2. Let's say if I was with the 60 degrees, well, my adjacent is root 3 over 2. That's not what we're looking for, right? We're looking for 1 over 2. So if I'm at 30 degrees, well, I think we've drawn this triangle backwards. This would be adjacent and a hypotenuse. This would be 1/2. I think we have these 2 backwards. This should be the other way around. I think this is root 3. And this is 1. Do you have it in your book? Let's quickly check. Okay, yeah, so we drew the triangle a little off, but here's the idea I get. If this is our angle we're working with, and we're doing cos, which means adjacent over hypotenuse, this is my adjacent and this is my hypotenuse. That gives me 1 over 2, which is exactly that answer. So in other words, we're dealing with that. We're dealing with the 60 degrees.
Mm-hmm.
So we have 60 degrees. But then I have to know that the wave is also going to hit 60 degrees twice. So that's going to give us my original 60 degrees. I'm still going to have to know that it touches here twice. And we also have to know that its extremities at 1, 1, and 1/8. That is going to be -1, 0, or 1. Okay. So for trig identities, your 2 major rules are, let's call it rule A, is sine squared theta, let's say, okay,
Mm-hmm.
plus cos squared theta equals 1.
Mm-hmm.
And rule B is that tangent theta is equal to sine theta over cos theta, okay? And what it is you can make many different rules from those. Do you remember the inverses? You usually have to know those 2. So tangent theta is equal to 1 over cotangent
Mm-hmm.
theta. Cos theta is 1 over, I think it's secant. Sometimes I get
I've
those
never
2.
seen those before.
No, and sine theta is equal to cosecant theta. Okay, well if you haven't had to do the inverses, then you're okay, and don't worry about those there. Those are inverse rules. If you don't have to know them, don't worry. These are the two major ones. Let's get a. So 1A says, what is it? Cos over sine, right? Yeah.
Mm-hmm.
So it says cos theta over sine theta is equal to 1 over tan theta, right?
Mm-hmm.
Okay, so we look at these. I'm going to decide I'm going to deal with the right side of this equation. And I'm going to replace tan, because we know tan is equal to sine over cos. So 1 divided by, and I'm going to replace it with sine theta over cos theta, correct?
Mm-hmm.
But I have a fraction divided by another fraction. That gets really confusing. So what I'm going to do is I'm going to change this into a fraction beside a fraction, or a number beside a fraction. So it's going to say 1 divided by, so remember that elementary style?
Yeah.
Sine theta over cos theta. Now, if you remember, when I'm dividing fractions, 1 is essentially 1 over 1. So I'm going to replace that with 1 over 1. Okay? When I'm dividing fractions, I turn them into multiplication questions, right? So I have 1 over 1 times, and I have to flip the second fraction. Cos theta over sine theta. And lo and behold, I have cos theta over sine theta.
Oh, okay.
That makes sense?
Yeah.